Hi, Peter. Welcome. Thanks for taking the time to talk to us about how University of Washington is using Neo4j. I think you have an interesting use case here that I wanted to share with the audience. Maybe you can start us off by introducing yourself.
Okay, my name is Pieter Visser. I am a solutions architect at the University of Washington. I'm in the enterprise data and analytics group, which is responsible for the data warehouse and also BI using SSRS and Tableau mostly.
Tell us a little bit about the business problem that you were trying to solve initially.
So we had three different business problems that we wanted to solve. Firstly, we were already using a metadata vendor out there that the application just was very complicated. And so only really two people could use that, our metadata managers, but none of the end users could use it. And so we had a new request for a new glossary. And that kind of gave us a moment to step back and say, is this how we want to continue this work? And the consensus was it's really not usable for the end users. The second one is that we are changing our HR system. And so we're going from a 30-year-old mainframe system to a new cloud-based system called Workday. And so we needed to figure out how to move our members, how to help them migrate from the mainframe system to the new system. The mainframe data currently gets stored in the enterprise data warehouse. So post the implementation of the new system, they will need to go look at new databases. And so how do we use metadata to essentially do change management? And then the third use case was how do we help people that are still in development of a project to document their metadata as part of that project's methodology. So for example, we might have lineage that we want to capture that then gets sent to our ETL team to get implemented. So how do we help them even before it's in production? How can we capture all that? So those are the three use cases that we try to solve.
I think a lot of people here may not have a very good idea of the scale and size of the University of Washington and how comparable is it to a large enterprise. So maybe you can talk a little bit about the size and scale so we can get a sense of the complexity of the environment there.
Well, the University of Washington is almost like a little city. We have about 50,000 students, but we also have about 30,000 people who work here. We have over 500 people in the IT department. So we have in just the data warehouse, we have 36 databases. We have about 6 terabytes of data every day that we move. We have 6 major subject areas, so anything from finance to HR to academics to research. We also have 6 hospitals, and so we're one of the largest public universities in the country, and we also have one of the largest amount of Tableau users, for example, or report users around. So I would say we're kind of in line with a really big enterprise.
So what made you decide on Neo4j? Did you evaluate other products as well before you came to the conclusion of using Neo4j and as the most appropriate solution for this system?
Yeah. So when I started working here, they already had a metadata solution. So they had a solution that was in SharePoint, and then they moved to a cloud vendor for metadata. But again, it really didn't work very well for anybody except for the metadata manager. Nobody could use it. And so when we started looking at how do we enhance it, we really took a step back and said, how would we do this, from scratch? So we looked at a bunch of vendors out there that could solve the problem, but none of them could really customize it the way we wanted customized. And so I started working really on a proof of concept, initially doing it in a relational database, and quickly ran into problems really because of the relational nature of metadata. Really, it when you talk about metadata, everything is related. So a table is related to a business term, is related to a report. Everything's related. And when you do that in a relational database, it just quickly becomes a nightmare. Same with that we wanted a schemaless database. And so we was doing it in SQL Server and had to create basically a table for every type. And when that didn't work, we tried to create a generic data structure, which works, except when you start wanting to create relationships between those, and all of a sudden you have to create grandparent relationships and things like that. So our initial proof of concept essentially in SQL Server didn't work at all. We just could not get to the relational model the way we wanted to. So we did a proof of concept with Neo4j. I actually saw a presentation by Notre Dame at a national conference on how they were using it. And because of the relational data, the relational nature, I'm sorry, of Neo4j, it was actually a pretty easy data model to implement. We essentially just worked with Notre Dame on creating our first data model on a whiteboard, brought that into Neo4j, imported data from Excel, and had essentially a technical metadata repository and a business metadata repository in a week or so. And then we put a search on top of that, and essentially that became a version 1 of our Knowledge Navigator. And it worked pretty well. And then from then on, once we proved that we could use a graph database, we started enhancing the product.
Tell us a little bit about how you evolved this solution over time and what sort of features that you've added.
So if you look at our 3 use cases, for example, the first use case is really just to create a metadata repository of business terms and technical terms. Now that's relatively easy with a relational database. You essentially just create a database to a table to a column. And so that part was easy, but then we actually, when you start adding our other business cases in there, like how do you show someone the change from this database to that database? So how do you say this table that you used to look at it in the old database is now related to this other table, or this table has now been discontinued? Those changes starts getting much more complicated in a relational database. Then the other use case was basically how do we show the impact on those tables? So one column becomes the source for another column, or one table impacts another column. Every single one of those things become relationships and become a foreign key relationship that is very, very difficult to maintain. So it just kept adding on the depth of our data structure. And then lastly is how do we actually use those tables within our reports? If a report contains multiple fields, and those fields then contain business terms, how do those relate to each other? So really from a relational database standpoint became a nightmare. Our initial proof of concept was to create a repository of business terms and technical terms. Your business terms were what we put in a glossary today, and then technical terms were basically databases to tables to columns. Then we put a search engine on top of that, actually still using Neo4j and actually just doing a context search within Neo4j. And that was our proof of concept. Can we essentially connect business terms up to technical terms? When we could show that visually, that's when we kind of had the aha moment, where it moved from being just a simple repository to people being able to see the context of the metadata. And so on a business term, you might say that this business term has related terms. But if the one that it's related to also has related terms, all of a sudden you start seeing it within context. And when that relates to a table or a column, the users start feeling like they can actually navigate, which is where the word Knowledge Navigator comes from. They can navigate the metadata because they can jump between business metadata and technical metadata seamlessly. So in addition to that, then we added a layer on top, which is a conceptual layer. So you would also call it a semantic layer. You put that on top of your business term. So that basically, you start on your conceptual layer, you get some context, you get to your business terms, and then you get your implementation layer, which is your tables and columns. And then you can say, well, this table is impacted by another table, or a report is impacted by this table. So if you change this table, then that report will be impacted. And then you can take it even a level lower, where you can say, well, this column within this table is a source for another column. And if you start doing that, now you get lineage. So we started implementing, we started taking a look at all our reports, our SSRS reports, and we looked at what are all the tables that make up this SSRS report, and then what are all the columns within those tables. And then we can step it back all the way to the enterprise data warehouse and all the way to the source system. And so we can do complete impact analysis now of all our tables within the data warehouse and their reports. And then we can do lineage. And then we've also been working out so one column plus another column makes a third column. So we can do calculations within that. And we can actually then bring that up visually to show people the lineage within our whole enterprise data warehouse. One of the interesting things about that, though, is within enterprise data warehouse, you usually pull data into a staging server and integration server. Now, people don't need to know that. Most of our end users don't need to know what goes on within the data warehouse. They just want to know what happened before it, and then what happens when it is out in a presentation layer. Now, we can actually stitch those together within Neo4j and then show the path only from the beginning and the end, and actually skip all the middle, the internal jumps, but show them the lineage of all the kind of the public lineage. And then for internal developers, we can show the internal lineage as well. Something that would be completely impossible to do in a relational database.
So tell us a little bit about how the business is starting to value this solution, and how your team has grown over time to support this.
So the HR replacement project is our biggest project probably ever. It's a multi-billion-dollar project, and so the project, the Knowledge Navigator, is the tool that we use to help change management for that. I mean, so this project impacts all 50,000 people who work here, and there are over 100 people who use that data every single day. So we are the single tool that are used for people to know what changes are coming, which reports are impacted, how they're impacted, which tables are impacted. So just from that perspective, it's huge. And also, we have 2 other replacement projects coming as well. We have the finance replacement project, and then we're replacing our student system right after that. And so we are able to use this metadata to actually show impact on those systems beforehand. And we can also show who the users are that we actually need to communicate to know about system changes coming. So that's been really big for us. In addition to that, I started this project really by myself about a year or so ago, and this has been a lot of buy-in. Our CIO has been absolutely a champion for this product, and we have now got a whole team around this product. We have a product manager, a QA person, a developer, a metadata manager, just a whole team built around this product to support the vision going forward. I think one of the strengths that we have is that we have just a large scale university that is full of metadata, and there has never been a single repository for all this metadata. So especially from a lineage perspective, that has been probably the one thing that everybody gets very excited about, is how can we finally, especially because we have some old mainframe systems and they get pulled into all these middleware systems, how can we actually trace that all the way through? One other thing I would just mention is one of our strategies now is to create really an integration platform. So essentially a web service platform in the middle that feeds into the data warehouse, but that actually is also the place where all our cloud applications go to. So to be able to document that integration platform, that's on probably one of our biggest projects that we're on right now. And that would show tremendous value to the university.
I think you found a very interesting use case here of really trying to do the impact analysis as you're trying to modernize the systems at the University of Washington, and using this product to help with that process. Can you tell us a little bit about what is in the future for this product? What sorts of additional features you want to add going forward? What's on the roadmap?
Yeah, one of the things that we have is we have a couple of different portals for BI specifically, and so we've been working on really integrating metadata into those portals and also into software really that's on people's machines. So, for example, being able to highlight something in Microsoft Word and then getting the definition for it right there. So in order to do that, we need to put on APIs on top of Neo4j to do that. So we've really been working with Neo4j and Elasticsearch really to kind of create public interfaces, not only to get data out, but then also for data in. So how do we get systems out there to give us metadata? So today we're really pulling metadata from all these systems, but in the future, especially from a lineage perspective, we want them to give us lineage of the systems they know about. So for example, they may know from A to B the lineage, and we might know, the next people might know from D to E. So we can't expect a single system to know them all, but if they each give us their piece, then Neo4j will help us to map together A to B, B to C, D to E, and so forth, and to give us that complete picture. We cannot pull that from every single place, and so ideally we would now create an API where they can give us that. I think most of the work we're doing today is actually to work on loading and validating the data before it comes in to the metadata repository. So we are able to go today to ER Studio, for example. We are able to go to Swagger. We are able to go to SSRS, SSAS, all these different places. But each one of those really need a connector, need some kind of tool to get that information out and convert it into the graph data. So that's most of the work we're doing. Once it's in Neo4j, that's easy. That's the stitching. It can do that, pretty easily. But it's the upfront work trying to get all that information that I'm really working on. So today I'm working on putting in cubes, for example, as well, and Tableau. In addition to that, we are just adding more and more types of metadata. So we're looking at diagrams, for example. We're looking at business process models, those kind of things. I think the challenge that we run into is trying to keep it simple from an end user perspective. Like I said before, we've had other metadata applications before, and they actually become so difficult to use that the end users can't use them anymore. Only the metadata managers can use it. So we do not want to become the thing that we actually try to avoid in the first place. We want to try and keep it simple, yet put enough information in there that we can give people the complete picture of where the metadata is and what it does. For example, just yesterday I was working on a problem that was talking about how a data was coming through our source system into the data warehouse, into a data store that then gets used by some reports. But that same data comes from a source system into a web service and then gets used by applications. Now, I've been working on pulling in all the web service metadata. And so all of a sudden I can do a query now that can actually see how my data from my web service is actually connected to the same data in my data warehouse. And those two actually connect to a business term, which will then in turn connect to a report. So my end user, for example, came back and said, well, I've just been told I can no longer I should no longer use this table. I should use a web service instead. How do I make these changes? Well, by having really the lineage all the way from the source system to both these tables, I can actually do a query and easily help that problem. Another feature that has been kind of interesting for us is from a governance perspective. We give people permissions to certain tables, for example, and we can say, well, so this table, you can see the table, but you can't see the social security number on that table, or so we have column-based security. Now, if you want to run a report based on that table, I can actually go back and look at that report, analyze all the reports, all the tables underneath that report, and then I can connect it all the way up to the data custodian that's responsible for that table. And now I can create a complete data governance security workflow for approval for a specific report. Where before, it was really a shot in the dark. You said, well, I wanted this report. I want access to this report. I'm just going to guess that I should ask ask the academics data custodian, for example. Well, now I can know exactly who the custodian is for each of those tables, each of those columns, by doing a query within my Neo4j database.
Peter, thank you for an excellent conversation. This is a very innovative use of Neo4j to do master data, metadata management, and a data lineage as well. Thank you so much for your time.
You're welcome. Thanks a lot.